Right, so 46 to 50. Let's see what we have here. So here it says that a company makes leather suitcases and uses a standard costing system. So what's important is we want to find what that standard cost is first. As each month, the company makes 2,000 standard cases using um, 4,000 kilograms. So we're expecting you to use 2 kilograms to make each standard case. Yes, that's what we're expecting. Right? And we're also expecting you to buy each of these at £6.40. That's what you're seeing right here. This is your standard information. Use 2 kilograms to make each suitcase and spend £6.40 on each of those kilograms. Now let's look at what actually happens. What actually happens is that you made to make these 2,000 suitcases, you used 3,800 kilograms, right? Yes. Now you should have used 2 times 2,000 suitcases. You should have used 4,000 kilograms, right? Because the point is you made, in terms of leather, you used 3,800 kilograms of leather versus 4,000 kilograms of leather. We are told that you actually do make the budgeted amount, right? Because if you weren't, we would be operating on the actual amount. But you do make 2,000 suitcases. So if I was asked to find the usage variance, I'd be finding the difference between these two. But I'm not asked that. I'm told that you did 3,800 kilograms and you spent whatever. I'll call this X. It doesn't really matter. You spent a total of 25,080. I can find how much you spent per kilogram. I can find that by simply dividing 25,080 divided by 3,800. I can find that. The question here is that you should have spent £6.40. So you should have spent £6.40 on the kilograms you actually did buy, right? So let's find out what that is. So you should have spent £6.40 times 3,800. So that would have been £6.40 times 3,800. You should have spent 24,320, but you spent 25,080. So the material difference is the difference, of course, between those two things. And you have, if you like, an adverse variance because you were supposed to £60 adverse variance. So that's 46. That's 46. So let's calculate the median donation. So let's line all of them up. We have 5, we have 10, then we have 10 again, then we have 10 again, then we have 30, then we have 40, then we have 50, then we have 50 again, then we have 100, then we have 100. Remember, median is a form of average. It's a type of average. So you have 10 donations, 1, 2, 3, 4, 5. So the median is the halfway house between the fifth and the sixth one because you don't. So 30 and 40, find the average of that. That takes you to 35 pounds. So that's your answer there, 35 £35. This looks like similar to what we were just talking about the previous question. So this is asking for the labor rate, very similar. So I can draw my graph again, and I'll see. Oh, this actually might not be as crazy. So the key point here is that we're trying to make the plan is to make 900 suitcases. So we're talking actually about 900 suitcases. So that's good. Okay, so let's see the scenario then. We want to make 900 suitcases, and we need 3,600. So we now know how many hours we should, right, make. We need, if you like, we need 4 hours for each suitcase. That's the plan. And the plan is to also pay £11 an hour. So I'm paying £11 an hour. So to make those 900 suitcases, you should be using 3,600 hours. But the question says that you used in the end 4,050 hours. So if the question had asked about usage, I would have compared these two and multiplied by the 11. But the question is asking for the material variance. So the question here is that, well, you should have used £11 You should have paid £11 an hour for those 4,050 hours. You should have done 11 times 4,050 times 4,050, which would have been 44,550. That's what you should have done. But you actually did, on these 4,050, you spent 42,525, right? So you spent more, forgive me, something up there. I don't know, it doesn't really matter what it is. Maybe it's £11, whatever, 35 times that. All I have to do is divide these two things together. So 42, well, let's just find it. 42,525 divided by 4050. 42,525 divided by 4050 is £10.50. Oh, wait a minute, sorry. You should have spent 11 times. Oh, sorry, forgive me. It's favorable. Sorry, I don't know why I thought that was adverse. Yeah, so you spent £10.50. You spent less per kilogram. So you spent this, and you should have spent this. So it's favorable, isn't it? It's a favorable variance. So let's find the difference between the two. 44,550 minus 42,525 takes us to 2,025. Favorable. It's a favorable variance. You've spent less than you should have. I thought this was 45 something 255 or whatever. But anyway, that's the picture of that. So the thing about rate variances or price variances is that we're interested in the actual. I'll just give you a formula here as well. I'm not a fan of them, but I'm just give you formula. Just, well, if you're just to maybe consolidate learning. Formula to consolidate learning. So what we have is really a formula where we could argue that when we're looking at rate variances, we're looking at actual price minus standard price times actual quantity. So we're interested in the actual quantity of input. That was 4050. So 4050 times whatever it was. I mean, you can do this as totals, right? So technically this is still APAQ minus SPAQ, right? That's the first thing. So this is a price variance. If it was the usage variance, you'll be having SPAQ minus SPSQ, which is the same thing as sort of saying SPAQ minus SQ. So you're comparing the quantities, as I've been doing all along the bottom line of that graph, and just multiplying that by the standard price. Yeah. So the answer there is B. 48 is B. Okay. Right. So let's look at 49. 49 again. So we have similar ideas here. It tells us that the material variance is nil. So I know I'm going to jump. So I know that I used 3 times 9,000. That's what I used. So that's 27,000. So you use 7,000 liters, right? So you should, it says the standard material price, you should have spent £9.50 times this 27,000. That's what you should have spent. Yes, so £9.50 times 27,000, and that's 256,500. That's what you should have spent. But it says that on these 27,000 liters, it says that the price variance is favorable, so you spent less. So I'm going to take off 5,400 off what I was meant to spend. So I actually spent 251,100. I spend this on the 27,000 liters. So the question here is, what is the value per liter? Now I can divide, of course, the 251,100 divided by 27,000, right? Divided by the 27,000. And that's £9.30. It's £9.30. Again, I mean, from the graph point of view, I think in the end you need to come to your, because you see that it says that the material variance, the usage variance is nil. So SQ and AQ are exactly the same. So all we can compare are just the variance is purely due to actual price and standard price, literally, right? Because that total, what you should have spent is just standard price times what you actually did spend, actual quantity, and what you did do in the end was actual price times actual quantity. And then finally, in this series here, you are given a formula. You need to follow the formula exactly. Some formulas sometimes use n, some don't use n. N minus 1 is just really a statistical way of reducing the error factor, because we're talking about samples. So the task is to find the mean. Oh, they've given you the mean, forgive me. So we call this x bar. And then to just work through the order of this and to find x minus. So you have x bar, you have x minus x bar, and then you have x minus x bar squared. So that's what these are the 4 headings we need. So I just like to work in order. I don't think it matters. 9.8, it means I capture everyone and I make no mistake. 10.1, 10.2, 10.4, right? So x bar is 10, 10, 10, 10. And here you have 0.3, you have 0.2, 0.2, you have 0.1, you have 0.2, and here you have 0.4. And then we square it. Yes, so 0.3 times 0.3 is 0.09. You have 0.04. You have 0.04. And then 0.1 times 0.1 is equal to 0.01. 0.2 times 0.2 is 0.04. And 0.4 times 0.4 is 0.16. So let's add all this together. That's what this is telling us to do. Add all this together. And then you have 0.09 plus 0.04 plus 0.04 plus 0.01 plus 0.04 plus 0.16. And that's all equal to 0.38 divided by n, which is the number of items, 1, 2, 3, 4, 5, 6, 6 minus 1, and then we find the root of that. So we have the root of 0.38 over 5. So 0.38 divided by 5 is 0.076, and let's find the root of that, and that's 0.2756, which is close to 0.28. Yeah, and that's how we find that. That's the standard deviation. So just plug in all those figures and you will arrive at the answer. And that is the end of that batch of questions. That was question 50.